This is for your 11 methods. We're going to look at question 4 from exercise 5H. Okay, so this is an application question of functions. So a piece of y 100 centimeters long is bent in the form of shape of a rectangle. X be the width of the rectangle. So with these type of problems, it's always important that you draw a diagram because it visually shows you, what to put in a label. So we know the width is X centimeters. Find the length of the rectangle in terms of x. Now, it's a bit tricky because we know the piece of wire is 100 centimeters long, so we know the perimeter of this rectangle has to be 100. Now, how do I work out, what the length is? Well, it's not as hard as you think, because we know that this is x. This also must be x. Okay, so out of the 100, we've already used up 2x, so I'm going to subtract 2x. Whatever's the remainder, okay, here must be, so this is the remainder of the rectangle left, because I used up x and x. So the remainder here would be 100 minus 2x. So if I were to divide this into 2, this would be 50 minus x, 50 minus x, because that must that must add up to 100 minus 2x, because if I add them together, 50 plus 50 is 100, minus 2x minus 2x is minus x is minus 2x. Okay, so you've got to think about like how to set this up. So drawing a diagram is extremely helpful in this case. Okay, so on the sack, we'll probably show that the length of the rectangle so that you've got, you know, you can do the rest of the question even if you don't get that. So that's A. A, the length would be 50 minus x. Okay. B, find the rule for A of x, the function of A which gives the area of the rectangle in centimeters squared. Okay, so A of x would equal length times width, which is x 50 minus x. Okay, and we've essentially got a quadratic. Part C, find the allowable values for x. Okay, so it's just asking for a sensible domain. Like, what are the possible restrictions on a rectangle? Okay, so we know that obviously x has to be greater than 0. Also, here's the length is 50 minus x. Now, 50 minus 6 has a restriction on its own because we don't want this overall to be negative. And it's overall going to be negative if x is greater than 50, because if x was 51, say, then the length would be negative 1, which is nonsense. So we need to make sure that 50 minus 6 is greater than 0. I rearrange. 50 x is less than 50. Okay? So combining these two restrictions, x is greater than 0 and x is less than 50, means that x must be between 0 and 50. Okay? And I suppose it can equal. I know the book doesn't like you putting equal, but the reason why is because if it does equal 0 or 50, you don't get a rectangle, because 50 minus 50 is 0, so you don't have a length, meaning you don't have a rectangle, or x is 0, which means you don't have a rectangle either. But that's okay. We'll just leave it like that. So we've done this, we've done this, we've done this. Find the maximum possible area for the rectangle and x4, which is the maximum curves. So we know a of x is a quadratic. So I'm going to go and sketch it on my calculator, on my CAS, just to get an idea of what it looks like. So let's go. We've got 50 x, 50 minus x, and I highly suggest you use the X button here because if you type it in, because I'm using a computer, I get used to like typing on the keyboard. Sometimes it doesn't work, so I'm just going to put it here and see if we get a answer. Now, if I look at it, I can't see a graph. Okay, so what you have to do is be sensible with what you're expecting for your graph. So you need to change the window. Okay, so you think this is a quadratic. We've got x-intercept at 0 and 50. Okay, so that gives you an idea of the domain. Okay, because 0 50 might be x 0 50 might be a good place to start. So x we go from 0 to 50. So instead of 50, you go 100, just to show the graph properly. Now the y might want to show as being not 100 but 50. Let's see if it works. Okay, looks decent, but our y value is still not big enough, so we'll have to try another y value. So try 200 maybe. So until we get a clear graph. Okay, even 200 is not enough. So you just readjust your window till you're happy with it. So I will try 500. Oh, perfect. I've got my graph. Okay, so you can zoom out even more and you can see the graph clearly. So I'm going to go analysis gsolve, root 0, 0, and 50, 0, and then my maximum would be 25, 6, 25. Okay, 25, 6, 25. Okay, so we've got a graph that looks like that. 25, 6, 25. And this is my area, this is my x, and this is 0, this is 50. So A max, the maximum area would be, you've got to be really careful. What does the 25 stand for, and what does the 625 stand for? Look at the axes. Your x stands for the width, and your y stands for the area. So the maximum area occurs when the width is 25 centimeters, and the maximum possible area is 625 centimeters squared. The x max width, so max width is equal to 25 centimeters. Okay, so you must answer the question because um, there's actually two parts to this question. In SAC, if you don't answer both parts, then you'll lose a mark, and it's not worth it because you would have done all the hard work. So hopefully that helps.